Example 1.2. Conservation of energy requires that the sum of all power absorbed by all of the elements in a circuit is 0. So that really means this here, that if I look at the total power, then the sum of all of the active powers plus all of the passive powers must be equal to 0. But if you include the negative sign in for active, then this really reads active must equal passive powers. So all of the elements of the all of the elements voltage and currents have all been specified. So we want to find out if conservation of power allows the circuit to occur. So here we go. So we've already defined what is passive and active. So if I look at a passive element, that implies that I have an element like this. And when I look at that, it has a voltage. And the current goes from the high potential to the low potential. That's what we mean by passive. When I look at active, I mean here that the current flows in the opposite direction. It flows uphill. So that means if I look at this guy here, that's the voltage right there. Now the current is going from the low potential to the high potential. The only way you can have an active element is if it has an EMF. So now I want to apply that to our circuit here. So what I'm going to do here is that I'm going to draw the current directions for the circuit. So if I look at this, I'm going to paste this guy in, and here it is. So now I'm going to follow the current. So if I look at this, look at the 2A here. So what I'm seeing here, I have 2 amps going in this direction, and therefore I have 2 amps going through that element. And if I look at this current right here, you could see in element 3, this current is going in this direction at 3 amps. Now, what I'm going to focus on now is I'm going to focus on this circuit here. So if I look at the right loop, you're seeing here that the 5 amps is going in this direction here. So it's going 5 amps here. Now note that this is minus of the current going in that, which then implies that the current of 5 amps is going in this direction. So now I could then go in and start to calculate the powers. There is one tricky bit here. So focus on element 1. And look what you're seeing here. So when I look at this, I have element 1 right here, like this. And note that we've already identified the current that's going downhill, like that. But look at the voltage. The voltage reads plus, minus, minus 2 volts. So this is equivalent to doing the following thing. That if I reverse the leads so that I take that minus sign and do that, then what you're going to see here is that my element is then going to look something like this. The voltage now becomes plus minus 2 volts, and my current is like this here. Now, note, I don't have to do that, but it's nice to be careful like that. So this is actually an active element since the current enters the positive terminal. So here we go. So now what we're going to do here is that we're going to sum the active versus passive powers. So here we go. So since the first element is already active, I'm going to start with the active. So here I go. So what are the active elements? We've already seen here that because the current's entering the negative terminal, this is an active element. Now, if I go to 2, you can see that the current enters the positive terminal. So element 2 is passive. Look at element 3. That current enters the positive terminal. So that one is passive. If I go to 4, you could see that the current is entering the negative terminal. So therefore, element 4 is active. And then here you could see that for element 5, it enters the positive terminal. So therefore, this is this guy right here. So now let's compute each of the terms here. So if I look at the first one is going to have what? It's current times voltage. So this has a voltage of 2 times 2. Then if I go to element 4, it's 5 times 4. So then this is 5 times 4. So this tells me that this is 24 watts. Now, if I look at element 2 here, I get 2 times 5. 3 is going to be 3 times 3. And then 5 is going to be 5 times 1. And that also gives me 24 watts. So this tells me here is that the active is equal to the passive. And so therefore, this circuit has passed as viable.